All right, so this is page 4 of the study guide, and problem number 12 and problem number 13 are actually very much like number 10 from the prior page. So we're going to factor. We're going to find the zeros from our factors, graph our inequality or graph our sketch, and then from this sketch we'll be able to figure out if we're talking about things that are above or below the x-axis. So problem number 12, I want to first start by factoring this thing. And what I notice is I've got 3, 9, 12, and 36. I'm actually going to divide every single part of this inequality, including the 0, by 3. It's going to make this problem just a little bit easier to work with. And if you can do that, go for it. Now, what you can't do is you can't divide by a variable, but you can divide by a constant. All right, if you divide by a variable, you're losing one of your critical values, which would be a problem. So now that I've got it much simpler, I'm going to go ahead and split it and factor by grouping. So my first two terms have an x squared in common. X minus 3 is left over. My second two terms have a negative 4 in common. X minus 3 is left over. The x minus 3's match. So I'm going to factor that out. This is factor by grouping, and then x squared minus 4. But it's factor by grouping up to this point, and now I'm going to factor this little piece a little bit more. X squared minus 4 is further factorable as the difference of squares. So x minus 2, x plus 2, the order that you write your factors will not matter. Now that I've got it in factored form, each one of these factors is going to give me a 0. So I'm going to do the quick sign flip. So this is x minus 3, which means it's going to turn into x equals positive 3. X minus 2 is going to turn into x equals positive 2, and x plus 2 will turn into x equals negative 2. So these are my zeros. They're also where I'm going to graph my x-intercepts. So I'm going to go over to my little sketch here and mark off, let's see, positive 3, positive 2, negative 2. I'm also going to mark negative infinity and positive infinity. So way back at the beginning of this problem, this was originally a positive x cubed. And so because it's a positive x cubed, I'm going to start down low here, curve through both or all of my x-intercepts, and end on a high part of the graph. So curve, 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 close enough. All right, it doesn't have to be absolutely perfect. We're just getting the basic shape of the graph. So now I can look to see where am I greater than or equal to 0. So greater than or equal to 0 are going to be the places where you are above the x-axis or exactly on the x-axis for those x-intercepts. So my interval here, this particular loop of the curve starts at negative 2 and ends at positive 2. So negative 2 to 2. I have another part of the curve that's going to start at 3 and go to infinity. So union 3 to infinity. Infinity will always take a parenthesis sign. The x-intercepts, because this is an equal to part for the inequality, will take brackets. And those are the two intervals that are greater than or equal to 0. So that's problem number 12. I'm going to slide on down to number 13. Same kind of problem. This time I'm dealing with a quadratic. So I want to factor it. Unfortunately, I can't start by dividing out a negative 2 because that's not going to work so well with x. So I'm just going to factor it as it is. So let's see, negative 2x, x. I'm kind of feeling like 2 and 3. Negative. Does that work? Let's see. Negative 2x times x is negative 2x squared. Negative 2 times negative 2 is positive 4. -3, that would get me 0. Yeah, that works. Okay, so I've got it in factored form. Now, however you need to factor it is how you need to factor it. Again, my guess and check is faster generally than dealing with the AC method, but the AC method is absolutely something you can do if you have a preference to it. All right, so each one of these factors is going to get me an x-intercept. So -2x minus 3 equals 0, x minus 2 equals 0. I'll start with the easy one, x equals 2. I'm going to add 3 to both sides here. So -2x equals 3, divide by -2. And I'm going to get x is equal to -3/2. It is totally okay to have an x-intercept that's a fraction. Not a problem. I just leave it as is, and then +2. This particular quadratic equation has a negative in front, so that means I have a concave down parabola. Okay, I'm going to go ahead and mark my infinities on the x-axis as long as I can actually draw. That is a horrible infinity. Let's try that. There we go. Slightly better. So I want things that are less than 0. So less than 0 are going to be things that are below the x-axis. So let's see. This particular graph, this particular section is going to go from -infinity to -3/2. Let's try and write with a pen and not the highlighter. So -infinity to -3/2. Union, this interval is going to go from 2 to infinity. Infinities always take parentheses. And in this case, because we are dealing with strictly less than, there's no equal to part to this curve, we're going to use parentheses at our x-intercepts as well. All right, so that's problem number 12 and 13. 14, we're going to do some factoring for A and B, and I think that's the end of this video then. All right, so I want to look for a GCF first. So these three terms can all be divided by 5x². So x² plus 2x minus 8. Yes. So that's my GCF, 5x². I just divided it out of everything. And now I want to see if I can factor this trinomial more. So I'm going to look what can multiply to -8 and add up to 2. So 5x², x, how about a +4 and a -2? So +4 minus 2 is 2. 4 times -2 is -8. So this is the completely factored form for part A. I'm going to slide on over to part B. Let's see. 3, 4, 18, and 24 do not all have a common factor. The 24 doesn't have an x, so I can't deal with that. What I can do is I'm going to split it. I'm going to look at the first two factors and find their GCF, look at the second two factors and find their GCF, and see if I can factor this by grouping. So the first two terms have a common GCF of x², so 3x plus 4. My second two terms can both be divided by 6, so +6, 3x plus 4. I'm going to take a quick check. I have a parentheses set of 3x plus 4 and another parentheses set of 3x plus 4, so I know I'm doing this right. I can factor that common set of parentheses out, and then the x² plus 6 becomes the leftover piece here. X² plus 6 cannot be factored anymore, nor can 3x plus 4. So that is the factored form for part B, factor by grouping. All right, so that's the end of page 4. Let me know if you have any questions or concerns for the upcoming